Every year, more than $60 billion worth of agricultural products from Italy enter the global market, directly setting the gold standard for the entire premium food segment, even though its farmland covers less than 1/10 the area of Texas. So how does Italy turn its fragmented farmland into a money-printing machine, generating economic value per hectare that is twice as high as Spain's and 3 times the global average? In this video, join Agriculture Insight as we step inside Italy's massive food production hubs, where artisanal craftsmanship blends seamlessly with advanced technology, and each unique microclimate creates signature flavors that can't be replicated anywhere else. Talking about Italy means talking about pasta. With nearly 4 million tons produced every year, Italy remains the world's #1 pasta producer, supplying billions of servings, from classic spaghetti to intricately shaped fusilli. This dominance begins with strict regulation. Under Italy's Italian Pasta Law 1967, all packaged dried pasta sold domestically must be made from 100% durum wheat semolina. Grown under the Mediterranean sun, this wheat has an exceptionally high protein content, giving pasta its firm bite and naturally golden color, without any additives. A key difference in premium Italian pasta comes from the use of bronze dies. While mass-produced, low-cost pasta is extruded through smooth Teflon dies to speed up production, high-quality Italian pasta is pressed through bronze molds. This deliberate choice creates a rougher, more porous surface, a clever mechanical design that helps sauce cling to every strand instead of slipping off, creating the perfect bite. After shaping, the pasta is dried on long vertical racks, allowing gravity to naturally stretch the strands straight and evenly. But the real secret lies in slow drying. Rather than blasting pasta with high heat for fast output, premium varieties are dried at temperatures below 50 degrees Celsius for up to 72 hours. This slow process preserves the starch structure and protein integrity, producing the firm, elastic texture known as al dente. Despite Italy producing more than 100 different pasta shapes, 3 varieties dominate the global market: spaghetti, penne, and fusilli, led by industry giant Barilla, which holds over 30% of the US pasta market. Leaving behind billion-dollar pasta strands, we step into one of the most iconic culinary production lines in the world. Each year, more than 2.7 billion pizzas are made in Italy, powering an industry worth tens of billions of dollars. At the heart of this system is Tipo Zero flour, an ultra-finely milled wheat flour with exceptionally low mineral content. To preserve authenticity, the Associazione Verace Pizza Napoletana enforces strict standards. Each pizza must be stretched by hand to retain its natural air pockets. The base must not exceed 3 millimeters in thickness, the crust edge no higher than 2 centimeters, and the use of a rolling pin is strictly prohibited. The most defining difference, however, lies in the baking process. Authentic Neapolitan pizza must be cooked in a wood-fired brick oven at temperatures between 430 and 485 degrees for just 60 to 90 seconds. This extreme heat causes the crust to rise rapidly, forming signature charred spots while the interior remains soft and moist, a texture that is very difficult to achieve with electric ovens. Did you know that farmers in Emilia-Romagna, the most fertile agricultural region in northern Italy, can actually use cheese as collateral for bank loans? More than 450,000 wheels of Parmigiano Reggiano are stored at Credito Emiliano, with a total value reaching $250 million, roughly equivalent to an entire mid-range jet fleet. This value begins with strict raw material standards. Only milk from cows fed on natural grass is allowed, no silage, no additives. Producing a single wheel weighing around 40 kilograms requires up to 550 liters of fresh milk, an intense level of concentration that pushes protein content to about 33%. At the dairy, the milk is heated in massive copper vats until it coagulates into a smooth, elastic curd. At the precise moment of readiness, cheesemakers use linen cloths to lift the steaming mass out of the way. With one decisive cut, the curd is split in 2, each vat yielding 2 wheels with nearly identical size and structure. After being placed into molds, gently pressed, and set into shape, The cheese is immersed in brine for about 20 days, a step that both develops its characteristic saltiness and forms a natural protective rind. It is then transferred to vast aging warehouses lined with towering wooden racks, where temperature and humidity are tightly controlled for 12 to 36 months, long enough for the flavor to evolve from fresh milk into rich, nutty, buttery complexity. At this stage, a unique inspection ritual takes place. Experts gently tap each wheel with small hammers and listen carefully to the sound vibrations to detect even the slightest internal flaws. Only those that produce a clear, firm, and uniform sound are fire-branded with certification marks, indicating a stable internal structure and qualification for continued aging. Wheels that fail this test have their markings removed and are immediately downgraded in value. Finally, at optimal maturity, tiny tyrosine krills begin to form inside the cheese, delivering a deep umami flavor and significantly increasing its value, in some cases even doubling it. To prevent counterfeiting, each wheel is embedded with a microscopic edible microchip in its rind, enabling full traceability from farm to consumer. The journey of Parmigiano Reggiano does not end there. Right after the cheese wheels are removed from the copper vats, the remaining way begins a new cycle, one in which part of Italy's more than 8 million pigs are raised on this nutrient-rich byproduct to produce one of the world's most prized cured meats, Prosciutto di Parma. While many people remain cautious about processed meats due to additives, authentic Prosciutto di Parma contains only 2 ingredients: pork and sea salt. After being hand-salted, the pork legs are hung in curing houses with open windows to catch the dry winds from the Apennine Mountains. These air currents act as a natural curing chamber, allowing the meat to mature slowly over 12 to 36 months, gradually concentrating its flavor. During the curing process, artisans periodically insert a thin metal needle deep into specific points of the ham, then withdraw it to smell and assess the internal fermentation. Even the slightest off aroma can lead to the entire leg being immediately discarded. Only those that pass every stage of inspection are branded with the Parma crown, a mark of authenticity and quality certification. Each approved leg typically sells for between $300 and over $800, comparable to a premium cut of bluefin tuna o toro served in high-end omakase restaurants. Meanwhile, salami represents a different approach: microbial fermentation. Coarsely ground meat is mixed with spices and wine, then left to allow beneficial bacteria to develop naturally. The white mold on the surface is not a sign of spoilage, but rather a protective layer that prevents harmful bacteria and contributes to its distinctive aroma. As a result, premium products such as salami felino can reach prices of $40 to $60 per kilogram, reflecting the value of time, craftsmanship, and natural conditions that no industrial process can truly replicate or accelerate. Now let's step out of the confines of the factory and into the open, to Piedmont, a region that produces over 90,000 tons of hazelnuts each year, ranking among the highest in Italy. Its ideal climate and soil conditions have given rise to the Tonda Gentile Trilobata variety, widely regarded by experts as top tier, thanks to its high whole kernel yield and exceptional oil content. To supply the production lines of Ferrero, the giant behind Nutella and Ferrero Rocher, harvesting has been almost fully mechanized. Once the nuts naturally fall to the ground at peak ripeness, high-powered machines sweep beneath the trees, collecting both nuts and dry leaves. A filtration system then removes debris, retaining only firm, high-quality hazelnuts, with a processing capacity of up to 2 tons per hour, equivalent to the work of hundreds of laborers. However, inside the factory, the true value of Italian hazelnuts lies in a closely guarded roasting stage. The temperature is precisely controlled to trigger the Maillard reaction, the key process responsible for creating the deep, rich nuttiness and distinct caramel notes found in Italy's iconic chocolate and hazelnut cream products. The world often associates France with premium wine, but in Italy, The industry is driven by more than 500 officially registered native grape varieties, exceeding the combined total of France, Spain, and Greece. With an annual production of over 50 million hectoliters, Italy consistently holds its position as the world's #1 wine producer, accounting for nearly 20% of global supply. That means 1 out of every 5 bottles poured worldwide comes from the sun-drenched hills of the Mediterranean, where fragmented terrain creates thousands of microclimates, allowing Italian winemakers to produce everything from crisp, sparkling wines to bold reds capable of aging for decades. In Piedmont, a historic northern hub, manual harvesting remains the gold standard for premium wines such as Barolo and Amarone. Skilled workers use specialized shears to carefully select only the ripest grape clusters. This method preserves the natural bloom on the grape skins, which contains wild yeasts, while minimizing bruising, a critical factor in shaping depth of flavor from the very beginning. Meanwhile, the vast estates of Veneto and Puglia, spanning thousands of hectares, rely on massive mechanical harvesters. Using high-frequency vibration systems to shake grapes loose at high speed, these machines can reduce labor costs by up to 70%. Night harvesting, when temperatures drop, further slows oxidation and helps preserve delicate fruit aromas before the grapes are sent for pressing. From this point, the Italian wine industry splits into 2 parallel yet complementary systems. At the high end, DOCG and DOC wines are aged in large oak barrels, often stored deep in natural stone cellars, requiring anywhere from 2 to 5 years for tannins to develop complexity and balance. In contrast, mass-market wines like Prosecco and table wines are produced in stainless steel tanks, ensuring that millions of bottles each year maintain consistency and fresh fruit character. A sharp contrast to the toasted, yeast-driven profile commonly associated with French sparkling wines. Revered as the white diamond of the kitchen, the Alba white truffle, the only agricultural product in the world that still resists all attempts at artificial cultivation, is harvested exclusively from the wild, with a global supply of just around 30 tons per year. Buried as deep as 25 centimeters underground, truffles depend on an extremely fragile ecosystem. Prolonged droughts in northern Italy are drying out the soil, disrupting the symbiotic relationship between the fungus and tree roots, and pushing the species closer to the brink of disappearance. To hunt this rare delicacy, Italians rely on the Legato Romagnolo, a breed with an exceptionally sensitive sense of smell, trained from as early as 3 months old to locate truffles without eating or damaging them, unlike pigs. The harvesting process is highly meticulous. Once the dog detects the scent, the hunter must carefully dig with a small spade, ensuring the delicate mycelial network remains intact to allow regeneration in the following season. Skilled hunters often kneel to the ground, using their bare hands to gently separate the truffle from the roots with absolute precision. Even the slightest scratch can cause its unique aroma to dissipate rapidly, erasing thousands of dollars in value within just a few hours. The white truffle harvest season runs from October to December. This extreme scarcity has fueled an underground competition among hunters, who often operate secretly at night to conceal their locations. In some cases, rivalries have escalated to the poisoning of competitors' dogs in an effort to eliminate their harvesting capabilities. This harsh and delicate process has driven the price of white truffles to between $6,000 and $10,000 per kilogram, up to 30 times more expensive than premium Wagyu beef sought after by the ultra-wealthy. Their flavor is formed by a complex blend of more than 120 volatile compounds, creating an aromatic spectrum that ranges from damp earth and wild honey to an intense, musky richness. First, we arrive at Zikang village in Zhejiang province. This small village of only about 1,000 residents may look peaceful, but it hides a nightmare for many people around the world. More than 3 million snakes of various species live together in less than 1 square kilometer, accounting for up to 10% of the country's total snake production. Can you guess what makes the locals willing to live alongside snakes? In fact, a professional snake farming household can earn between $55,000 and $68,000 per year, making snake farming a highly sought-after occupation in rural areas. The process begins with female snakes that reach the standard age of 9 to 10 months. To optimize the survival rate of the brood, farmers apply a controversial but crucial intervention technique: stitching the snake's lips with fine thread when the egg-laying season begins. The purpose of this is not to protect humans, but rather a technical measure to eliminate the female's instinct to eat their own eggs. With a yield of 12 to 21 eggs per clutch, manual collection must be carried out strictly every 2 hours. However, this is an extremely tense and dangerous period, as the mother snake remains in a defensive state, ready to strike at any moment. Collectors use a wooden stick with a metal hook at the end to skillfully lure the mother snake away from the nest. The operation must be fast, precise, and extremely cautious. Courage alone is not enough, as the price to pay could be a fatal bite from a highly sensitive mother snake. Moreover, even a slight delay can cause the embryos to die due to changes in temperature and humidity, rendering all the care efforts meaningless. Once removed from the nest, the eggs are taken to the incubation room. There, technicians inspect them using a flashlight to check embryo development and detect abnormalities. Qualified eggs are placed into incubation trays with strictly controlled temperature and humidity, while any discolored or irregularly sized eggs are immediately discarded. As they enter the growth stage, the snakes are transferred to standard cement enclosures measuring 0.5 meters in height and 1 meter in width, reinforced with sturdy steel mesh. Here, they are provided with a high-protein diet consisting of frog meat or baby chicks, fed 2 to 3 times per week. A 1-month-old group of snakes can consume up to half a kilogram of baby frogs per day to ensure rapid muscle development and the accumulation of high-quality venom. For individuals that absorb nutrients poorly or refuse to eat, farmers carry out a force-feeding process by using a stick to place food directly into their mouths, ensuring the entire group reaches the required weight before harvesting. This level of strictness is the foundation behind the immense economic value of the final products. In specialty restaurants, snake meat is prepared into stews or soups, priced between $50 and $100 per kilogram, depending on the species. In addition, snake wine remains an iconic product in traditional East Asian medicinal culture. Jars containing whole cobras or banded crates can sell for up to $1,000, based on the belief that they enhance vitality and help treat joint-related conditions. Leaving the snake farming village in southern China, more than 27 million buffalo are undergoing a major genetic transformation. For decades, this animal was shaped for labor rather than economic value. They were mainly used for plowing and freely grazed on river floodplains or steep hillsides. This farming method relies on a unique biological mechanism. Buffalo must soak in water or mud for 2 to 4 hours each day. With an extremely limited number of sweat glands, wallowing is almost the only way for them to regulate body temperature, remove parasites, and protect their skin from harsh heat. However, this nature-dependent farming approach is gradually being restricted due to strict government regulations on resource management. Large-scale free grazing has been limited in many areas to prevent forest soil erosion, protect biodiversity, and especially to eliminate the risk of water pollution caused by livestock waste. It is precisely these environmental constraints that have driven a shift toward high-tech, intensive farming models. By crossbreeding local buffalo with imported breeds such as Murrah and Nili Ravi, experts have increased milk yields from 500 kilograms to 2,500 kilograms per cycle, transforming an outdated draft animal into a true money-making machine. In Guangxi, the buffalo milk capital supplying up to 60% of the nation's total output, buffalo are no longer free-grazed but are instead raised in large-scale facilities with temperatures maintained below 30 degrees Celsius. This controlled housing, combined with automated TMR, total mixed ration feeding systems, ensures complete consistency, producing premium milk valued at up to $6 per liter, 4 times the price of cow's milk. The reason buffalo milk can command such high prices lies in its superior biological properties. It contains twice the fat yet less cholesterol than cow's milk. Notably, with 58% more calcium and 40% more iron, along with A2 protein that is easier to digest, buffalo milk has become an ideal alternative for children, the elderly, and those sensitive to lactose. In Luan City in eastern China, hundreds of millions of geese are quite literally laying golden eggs, producing hundreds of thousands of tons of feathers each year, an economic value that rivals that of their meat. Leveraging its dense freshwater ecosystem, China has come to dominate this entire industry, controlling up to 90% of global meat production and 80% of the global feather market share. The journey of a goose begins in industrial hatcheries, where temperature and humidity are precisely controlled. After collection, goose eggs are carefully inspected under light before being placed into incubators. After about 28 to 35 days, goslings hatch from the selected eggs, healthy and ready to begin a new life cycle. They are then kept warm, carefully nurtured, and provided with adequate nutrition to ensure stable development. However, for young poultry, the brooding stage is extremely sensitive. Without proper control of temperature and hygiene, goslings can die in large numbers due to disease or thermal shock. As waterfowl with high activity needs, geese require ample space to develop feathers that meet quality standards. As a result, farms in Luan typically combine enclosed farming systems with large natural water areas. After about 120 days, when they reach a weight of 4 to 6 kilograms, the feathers achieve the necessary elasticity and insulation, key criteria that unlock a multi-billion-dollar value chain. By controlling the neck, the most maneuverable part of the body, workers can quickly separate each goose from the flock and place it into transport cages, while keeping the feather structure intact and undisturbed. From there, at the factory, the feathers undergo a rigorous industrial processing line. Raw feathers are separated using airflow to classify them by weight, then pass through a series of washing, sterilization, and centrifugal drying processes to completely remove impurities and moisture. Finally, they are dried and fluffed to achieve maximum loft before being inspected and precisely filled into premium bedding products, where goose down offers superior insulation and is significantly lighter than duck feathers of the same weight. But it doesn't stop there. Goose feathers have also unlocked another billion-dollar market: badminton shuttlecock production. Few people know that to create a shuttlecock that meets international competition standards, exactly 16 nearly identical wing feathers are required, carefully selected from the healthiest mature geese, an essential factor in achieving a stable flight trajectory that synthetic materials still cannot fully replicate. No longer confined to the ground, China's livestock industry has expanded skyward, where more than 600 million pigeons operate like mobile protein production lines, ready for market in just 21 days and delivering economic efficiency 3 times higher than traditional farming. In multi-tiered cage complexes stacked high to the ceiling, the key to this ultra-fast capital turnover lies in the 2+2 model combined with artificial feeding. In nature, parent pigeons must produce crop milk to feed their young, a process that consumes significant energy and prolongs the reproductive cycle. Chinese agricultural engineers have overcome this biological limitation by allowing parents to raise the chicks for the first 7 days, then separating them and transferring them to automated feeding systems. With the support of technology, a nutrient mix that perfectly mimics crop milk is directly injected, allowing young pigeons to increase their body weight 8-fold in just 3 weeks. By removing the burden of parental feeding, adult pigeons can immediately enter a new egg-laying cycle, boosting productivity from around 10 broods to 25 to 30 chicks per year. As a result, meat pigeons reach market standards in less than 1 month. Do you know how thousands of pigeons are transported at once without losing a single one? This is where specialized ventilated trucks come into play, tightly packed with stacked plastic cages, maintaining a massive supply flow from high-rise farms directly to centralized slaughter lines within just a few hours. Beyond providing ultra-fast protein, internal organs such as pigeon liver and heart are often valued up to 5 times higher than regular white meat due to their concentrated iron and micronutrient content, especially the liver, one of the richest natural sources of iron in the food world. In some premium markets, they are even sought after as animal ginseng, although this term is more rooted in folklore than science. Moving into the inland waters of Zhejiang province, you are faced with a massive biological gemstone factory, one that controls up to 95% of the global supply of freshwater pearls. At the core of this system lies a breakthrough technique: multi-point mantle tissue grafting. Unlike saltwater pearls, where each oyster is implanted with a single solid nucleus, technicians here make dozens of ultrafine incisions in the mantle of a living mussel, then insert epithelial tissue taken from another individual without using a hard nucleus. As a result, each mussel no longer produces just one pearl, but becomes a multi-point production system, capable of cultivating 30 to 50 pearls simultaneously in a single cycle, increasing output density dozens of times compared to traditional methods. To ensure consistent quality at an industrial scale, the entire living environment is tightly controlled. Instead of resting in unstable bottom mud, millions of mussels are suspended in mesh bags within oxygen-rich water layers, where growth conditions are continuously optimized. At the same time, biological sensor stations spread across the lake monitor algae density, the primary food source, in real time, maintaining a stable and optimal nacre secretion state, which directly determines the luster and color of the pearls. After 3 to 5 years of nacre accumulation, the mussels are harvested and manually opened with precise incisions to release large quantities of pearls, ranging in color from milky white to pinkish purple. The pearls are then sent through a surface treatment line, where they are cleaned and polished using ultrafine abrasives such as aluminum oxide powder or industrial diamond powder, creating a near mirror-like luster before entering the grading stage. This is the most labor-intensive phase, as thousands of workers must sit for hours to manually sort millions of pearls based on size, shape, roundness, and reflectivity, factors that directly determine their commercial value. With its concentrated calcium and amino acid content, Chinese pearl powder can retail for up to $200 per 100-gram jar when packaged as a premium cosmetic ingredient in the US market. Beyond that, even the shells left after pearl extraction are ground into mineral additives for animal feed, ensuring the entire system operates under a single principle. Not a single gram of material goes to waste. On the international market, Chinese pearls have the advantage of low prices thanks to large production volumes and a wide variety of designs, making them highly accessible. However, their quality is often inconsistent, with luster and durability sometimes inferior to pearls from Japan or Australia. In contrast, other countries focus on higher quality, but their products tend to be significantly more expensive. To supplement its water supply, Israel chose an exceptionally smart approach: desalinating Mediterranean seawater. With a long coastline, stable salinity, and minimal exposure to natural disasters, these waters allow mega-scale plants to operate 24/7, regardless of weather conditions. The key lies in reverse osmosis technology. Seawater is forced through ultrafine, semi-permeable membranes under extremely high pressure, allowing pure water molecules to pass through, while salts and impurities are retained, producing water that meets domestic consumption standards. What truly sets this technology apart, however, is not filtration alone, but energy recovery systems. By harnessing residual pressure from the concentrated brine stream to compress incoming seawater, Israel has reduced electricity consumption by up to 40%. As a result, production costs have fallen to a record low, less than $1 per cubic meter, among the lowest in the world. The outcome is striking. Around 80% of Israel's domestic water supply now comes from the sea, virtually eliminating dependence on natural rainfall. However, desalinated water is extremely expensive to produce and transport, so it is prioritized primarily for domestic use. To sustain large-scale agriculture in the desert without draining the national budget, Israel activated an often overlooked resource: urban wastewater. This solution has propelled Israel to the global lead, with up to 90% of its wastewater reused, 3 times the rate of the United States. At megascale treatment plants, wastewater containing organic pollutants and microorganisms is fed into massive aeration tanks. Here, bacteria act as natural decomposers, consuming and breaking down harmful organic compounds, transforming dark, contaminated flows into basic clean water. Next, pressure filtration systems and centrifuges completely remove solid impurities and sludge from the stream. This closed-loop process ensures that not even the smallest debris escapes, preparing the water for the most critical purification stage beneath the ground. The water is then directed to desert reservoirs for soil aquifer treatment, the most crucial step in the water regeneration chain. It slowly percolates through sand layers, reaching depths of up to 100 meters, using the earth itself as a vast biological filter to fully eliminate bacteria and remaining contaminants. From this point, the regenerated water reaches a purity comparable to drinking water, sustaining over 60% of agricultural land in the Negev desert at a cost only 1/3 that of desalinated water. But water alone is not enough. For centuries, drawing water from wells was one of the most backbreaking tasks in arid regions. Jewish settlers in the Negev and the Jordan Valley were forced to haul bucket after bucket up from the ground, then carry heavy canisters on their shoulders to irrigate their fields. Water was scarce, labor was intense, and most of that effort simply evaporated under the desert sun. Today, more than 90% of Israel's cultivated land has been transformed by drip irrigation technology. While Israel did not invent the principle, it was the first country to commercialize it and turn it into a fully integrated, large-scale system, operating reliably across open fields and sealed greenhouses alike. After passing through filtration units, water is pushed into main pipelines and then distributed into smaller lateral lines running parallel along planting rows. Along each line, drip emitters are placed 40 to 60 centimeters apart, precisely where root activity is strongest. So water does not spread wastefully, but is delivered exactly where plants actually need it. Unlike flood irrigation or overhead spraying, drip irrigation fundamentally solves the long-standing inefficiencies of manual watering. Pressure-regulating valves and automated controllers allow farmers to precisely control flow rates and timing, delivering water steadily into the root zone. As a result, leaves remain dry, soil surfaces are left undisturbed, and most importantly, water loss through evaporation is nearly eliminated. In mushroom farms, where thousands of delicate caps have no roots to draw water, drip irrigation becomes a tool for controlling life itself. Water is supplied in ultra-small doses, slowly absorbed, just enough to maintain optimal humidity for mycelium growth. Here, drip irrigation is no longer about watering, it is precision management of the microbial environment. And now, welcome to the Jordan Valley, the lowest place on Earth, and also the most unforgiving heat basin in Israel. Here, where temperatures of 45 degrees Celsius can scorch nearly all life, and salt-crusted soil gleams white like snow, conditions long considered a death sentence for crops become an absolute advantage for date palms. The medjool date, often called the black gold of the desert, is the star of this landscape. Extreme heat triggers intense sugar accumulation, while soil salinity naturally eliminates pests, allowing the dates to grow completely clean, without chemical intervention. However, producing export-grade dates with near-perfect uniformity requires deep technical intervention. Each mature date palm needs around 700 liters of water per day at the peak of summer. This massive volume is drawn from the Jordan River and delivered through intelligent drip irrigation systems, directing each drop precisely to the root zone, sustaining life without increasing soil moisture, a critical factor in preventing fungal growth on the fruit. From August to October, as harvest season begins, date clusters do not ripen uniformly and are therefore monitored closely day by day, cut only at the exact moment when sugar content reaches its peak. Harvesting is assisted by specialized hydraulic lifting platforms, allowing workers to reach individual fruit bunches at heights of up to 20 meters. Each cluster is cut by hand, then slowly lowered using pulley systems to prevent impact or surface damage. The moment the dates leave the canopy, the clock starts ticking. Within a 6-hour golden window, they must enter processing facilities for controlled cooling and drying. This critical step locks in the fruit's flesh structure and its concentrated sweetness. Few realize that while medjool dates can be grown in many regions, only in Israel do they reach such exceptional size, richness, and a soft, toffee-like texture that the world relentlessly pursues. Once a luxury tribute offered to Roman emperors, medjool dates today generate up to $350 million USD annually. With an average yield of 120 kilograms per tree, double the productivity of California, America's date capital, this stands as the clearest proof of Israel's mastery over precise water control, ripening timing, and sugar accumulation rhythms, something even temperate climates have yet to achieve. A naturally grown cherry tomato plant yields only 20 to 40 fruits. But in Israel, where nearly the entire national tomato export supply is produced, a single plant can deliver up to 400 tomatoes. The secret lies in a suspended growing system using sterile hydroponic substrates, which completely isolates the root zone from nutrient-poor desert soil and cuts off the risk of infection by tomato brown rugose fruit virus, TBRV, the most dangerous threat to tomatoes in hot, humid greenhouse environments. This record-breaking productivity is sustained through precision drip irrigation, where every drop of water and nutrients is delivered directly to the roots, maximizing sugar accumulation and achieving high brick sweetness without waterlogging or losses from evaporation. And to produce clusters with crystal-like sheen and consistent flavor, Israel relies on a factor no machine can replace: bumblebee pollination using polyam hives. In sealed greenhouses, where honeybees often lose orientation, bumblebees are the only effective vibration pollinators. increasing fruit set rates by 20% and creating uniformly plump, glossy, deep red tomato clusters. After roughly 100 days of intensive nutrient accumulation, when a uniform red hue spreads across the fruit and the skin reaches a crystal-like gloss, the king of sweetness is ready for its peak harvest. Harvesting is carried out entirely by hand. One hand makes a clean cut with pruning shears, while the other gently supports the fruit to protect its delicate skin from even the slightest abrasion. This level of precision is mandatory to meet the requirements of export markets. Over 80% of production is shipped to Europe and Russia, regions known for their exceptionally strict standards on appearance and biosecurity. With yields reaching 300 tons per hectare, Israel's greenhouse model has set a new global benchmark for productivity. Despite high infrastructure costs, its superior quality control and a record 40% reduction in water consumption have created a competitive advantage unique to Israel on the world's agricultural map. Moving beyond greenhouses, Israel is bringing artificial intelligence into open fields with autonomous apple harvesting robots. As global labor shortages intensify, these robotic fleets are gradually replacing human workers during harvest season. Equipped with computer vision, the robots scan entire canopies, assess ripeness and size, and detect even the smallest blemishes on apples while they are still on the tree. Once a fruit meets the standard, it is picked using vacuum suction grippers or soft clamps, ensuring zero surface damage. The true breakthrough lies in 24/7 operation. These robots can work through the night under specialized LED lighting, enabling rapid harvests ahead of unpredictable weather. The result, up to a 50% reduction in labor costs, while simultaneously upgrading fruit quality. This is how Israel transforms traditional apple orchards into intelligent production lines, as precise and efficient as a high-tech manufacturing plant. For thousands of years, the olive tree has stood as a symbol of peace and prosperity across the Mediterranean. By 2025, global olive production is expected to exceed 23 million tons, harvested from September's green fruit to January's black oil-rich olives. Among them, Spain continues to dominate with more than 8 million tons each year, far surpassing Italy and Greece, thanks to the millions of hectares of olive groves in Andalusia and the region's early adoption of advanced mechanization. To meet this massive demand, traditional hand-picking methods have been replaced by modern harvesting machines. One of the most impressive is the Pellenc Expand R5D90, a true technological beast. Its massive yellow catching frame extends up to 10 meters, wrapping around the base of the tree. A powerful hydraulic shaker then vibrates the trunk and branches, sending ripe olives cascading down like rain. The fruits are immediately carried onto conveyors that strip away leaves, remove debris, and transfer clean olives directly into storage bins. With a capacity of 4 to 5 tons per day, this machine replaces the work of dozens of laborers, making it especially effective in large-scale groves across Andalusia, Tuscany, and Crete. However, the next leap forward comes with self-propelled olive harvesters like the New Holland Broad series, designed specifically for super high-density orchards. Instead of shaking each individual trunk, these machines drive directly through densely planted rows, using dual shakers and conveyors on both sides to gently strip away 15 to 20 tons of fruit per day from the canopy. In terms of yield, a modern hectare of olive trees can produce 3 to 5 tons of fruit, equivalent to around 600 to 800 liters of extra virgin olive oil, depending on the variety and growing conditions. From there, Millions of tons of olives are transformed into extra virgin oil, cosmetics, soaps, and even biofuels, fueling an industry worth more than $15 billion annually. Truly, olives remain the liquid gold of the Mediterranean. Delicate and easily bruised, zucchini, also known as courgette, is one of the most fragile vegetables to harvest, yet it is considered among the easiest crops to grow in the world. Within just 45 to 60 days after sowing, the plants begin to produce fruit, and throughout the season, farmers must harvest almost daily to keep each zucchini tender, crisp, and at its highest market value. Farmers use small knives to gently cut the stems, taking care not to damage the thin, sensitive skin. Left on the plant for just 1 or 2 extra days, the fruit can grow 3 to 5 centimeters longer, becoming oversized and losing commercial value. Today, the United States, Italy, Spain, and Mexico are among the world's largest zucchini producers. The United States alone harvests over 400,000 tons annually, while the European Union produces more than 1.1 million tons in total. Thanks to its rapid growth, continuous yield, and strong consumer demand, zucchini has become one of the 10 most widely cultivated vegetables worldwide. Today, more than 90 million beehives worldwide produce around 1.8 million tons of honey each year, supplying markets from Asia to Europe and North America. From May to September, the peak harvest season takes place across the Northern Hemisphere, when beekeepers carefully lift heavy honeycombs from their hives to collect nature's liquid gold. Smoke from a traditional bee smoker is used to calm the colonies and reduce the risk of stings. Each frame is then gently removed, often covered with thousands of bees. On average, a single frame can hold 2 to 4 kilograms of honey. The beekeeper must work quickly and precisely, brushing the bees away before placing the frames into sealed transport boxes. Globally, beekeeping is thriving. China leads the industry, producing over 450,000 tons, nearly 25% of the world's honey supply. The United States, Turkey, Argentina, and India also rank among the top producers. In Europe alone, more than 600,000 people are involved in apiculture, not only for honey, but also because of bees' crucial role in crop pollination. Once harvested, the honeycombs are delivered to processing facilities. There, the thin wax cappings are sliced off by hand knives or automatic uncapping machines. The frames are then placed into centrifugal extractors, high-speed spinners that force the honey out of the combs and into collection tanks. On the international market, the honey industry is valued at more than 10 billion USD annually, serving not only food but also pharmaceutical and cosmetic industries. Every drop of honey that reaches consumers represents a journey that is both artisanal and industrial, distilled from the tireless labor of millions of bees. Across the vast fields of Europe and North America, green peas, small, crisp, and sweet, demand a harvesting process timed down to the very hour, as more than 20 million tons must be gathered for the 2025 season. Specialized harvesters like the Oxbow series, equipped with cutting blades, conveyors, and separating fans, can collect up to 8–10 tons of peas per hour. The process runs seamlessly. At the front, Blades slice close to the ground, pulling entire plants into the machine. Inside, beaters and airflow separate the peas from their pods, leaving only the vibrant green kernels. On average, each hectare yields 5 to 7 tons of fresh peas, and the harvest window lasts only 2 to 3 short weeks in summer. On the market, these peas are widely used as ingredients for soups, pasta dishes, salads, and stews, as well as in the form of frozen peas and canned peas destined for export.